The third topic we're covering today is combinations. Combinations is a way to count objects where order doesn't matter. Again, permutations is where order matters. Combinations, really great examples include playing cards or ordering a pizza. All right. So when we look at problems in this situation, there are 16 people on a team. 2 are selected to be a captain. How many ways can captains be chosen? Well, if it mattered, if order mattered, we just do 16 times 15. Once somebody's picked for captain, you can't pick them again. So 16 times 15. In this case, I don't care the order of captains, so I'm going to divide by 2 factorial, very similarly to the distinguishable permutations. All right. So if I calculate this, 16 times 15, that would be where order matters. I divide by 2 factorial because I don't care what order the captains are chosen. They're going to be captains regardless. When I run this calculation, I get 120 different combinations. Okay, the formula is down here. And essentially, like we said, combinations are your permutation calculation divided by the number of ways you can order those objects you took. Okay, order does not matter. Card problems are really good to look at for these. All right, so when we look at 5 card hands that are possible, we know there are 52 cards in a deck. All right, if we're looking at 5 card hands, order doesn't matter. Once you're dealt a card, it doesn't matter how you arrange them in your hand, it's still in your hand. So all we have to do is 52 choose 5. You can either do this out by hand the long way, or you can use your calculator. If you use your calculator, the combination function is under your math menu, arrow over to probability, and it's the third line down. If you do 52 C5 or 52 choose 5, you'll wind up with 2,598,960 possible poker hands. All right. The next situation, we take things a little bit differently. We're looking at 5 card hands of the same suit. So all clubs, all spades, all hearts, or all diamonds. We know there's 4 suits available. But within each suit, we want to calculate the number of hands that are possible. Well, we know there's 13 cards of each suit. We want to pull 5 of that same suit. So if we do 4 times 13, C5, we wind up with 5,148. If you're a fan of poker, this is the number of flushes that are available in the game of poker. All right. Example C, we're getting a little more specific. We have 5 card hands. We're looking at 3 kings and 2 queens. Well, we know there's 4 kings in the deck. We know there's 4 queens in the deck. We don't care the order we get them. We just want to make sure we have 3 kings and 2 queens. If you remember from our first lesson, whenever we're counting events, we multiply them together. So what is 4 choose 3 times 4 choose 2? Well, 4 times 6 is 24. All right. Moving on to the very last example. All right. Calculating things here. We have a list of veggies and meat. I understand cheese is not a vegetable. Don't harass me about it. It's just part of the veggie list. All right. So we want to choose exactly 2 veggies and 1 meat. Keep in mind, order doesn't matter. You're still going to get it in an omelet. So we have 6, and we want to choose 2 veggies. We have 4 meats. We want to choose 1. So we multiply those together, and we wind up with 60 different combinations of omelets are possible with 2 veggies and 1 meat. Things are going to get a little more complicated when we put the word at most. At most would mean we could have an omelet with 3 toppings. We could have an omelet with 2 toppings, 1 topping, or we could just order eggs. All right. In this situation, we want to take each of those results separately and add them together. We wind up with a total of 176. If we have at least 3 choices, that would mean I want to do 3, 4 toppings, 5 toppings, 6 toppings, 7 toppings, 8 toppings, 9 toppings, or 10 toppings. That's a lot of things to calculate. So what we could do is look at the reverse, which is 0, 1, and 2. If I could figure out this number and subtract it from the whole, that is going to be easier than adding up these separately and going from there. So 10 choose 0 plus 10 choose 1 plus 10 choose 2. All right. If we look at this, again, we're going to subtract them from the total. Question is, what's the total? Well, you have 10 toppings and you have 2 choices for each of them. So if you think about it, you have 10 toppings. You can say yes or no for each of them. So that's where the 2 to the 10th comes into play. If we take 2 to the 10th and we subtract from the total, like we were talking about, you wind up with 968 different outlets that are possible. This idea is kind of the complement. So you can have this event or this event. When you add them together, it equals the total number of outcomes, which in this case, we have 10 toppings. The total number of outcomes is 2 to the 10th. You can say yes or no to each topping. Either way, you could have done it this way and taken 3, 4, 5, 6, 7, 8, 9, 10 and added those together. But again, it's just more calculations for you to do in the long